Hi friends, in this video, we will understand in detail how throughput plays a vital role in deciding the decoding capacity of SATATYA devices. SATATYA devices are classified into three categories based on the total number of cameras that can be connected with them. First 8 channel, second 24 channel, and third 64 channel. Throughputs of these devices are approximately 50 Mbps for 8 channel, 144 Mbps for 24 channel, 256 Mbps for SATATYA NVR64S, and 384 Mbps for SATATYA NVR64P. We will take the example of SATATYA NVR24P. Also, we will presume two conditions. First, no user is watching the cameras on TV monitor. Second, recording of all cameras is on. Throughput of any SATATYA device can be divided into three further categories. First, downstream, second, stream limit, and third, upstream. Let us understand about downstream. Downstream is the stream transferred from the IP camera to SATATYA device. Throughput of SATATYA NVR24P is approximately 144 Mbps. Downstream can be easily calculated by multiplying the number of maximum cameras that can be connected with the NVR with the bitrate of each camera. In our case, the number of maximum cameras of SATATYA NVR24P is 24. The user can watch the cameras in mainstream or substream. Bitrate of each camera recommended by Matrix is 2 Mbps for mainstream and 1 Mbps for substream. Considering the user watches all cameras in mainstream, downstream is 24 into 2, that is 48 Mbps. As the recording of all cameras is on, the downstream in this case will be 16 Mbps, assuming that the recording stream is mainstream, even if no user is watching any camera. Bitrate of each camera can be kept high. However, it is recommended not to exceed this limit for better performance of the device. This completes the understanding about downstream. Let us understand about stream limit. Stream limit is the limit of SATATYA device to take in or give out the stream of cameras. In stream limit is the maximum number of streams of cameras that the device can take. It is equal to the total number of cameras that the device supports. In our example of SATATYA NVR24P, in-stream limit is 24. Outstream limit is the maximum number of streams of cameras that the device can give. It is equal to 3 times the total number of cameras that the device supports. In our example of SATATYA NVR24P, outstream limit is 24 into 3, that is 72. The stream limit can be seen in device status option followed by system and more. Note that this is the combination of live and network streams. Live streams are the ones projected on the monitor connected with the device. Network streams are the ones projected on user PCs through SATATYA device client. This completes the understanding about stream limit. Let us understand about upstream. Upstream is the amount of bandwidth allocated to a user who is logged into SATATYA device client. consider a scenario in which user 1 is watching all 24 cameras connected with SATATYA NVR24P at the same time in PC. Also, it is considered that optimized bandwidth flag is not enabled at this time, resulting in deliverance of only mainstream of all cameras irrespective of the layout set. Bitrate of each camera connected is 2 Mbps. In this scenario, the bandwidth allocated to the user by SATATYA device will be 24 into 2, that is 48 Mbps. Now downstream in this case is 48 Mbps and upstream is 48 Mbps. Also, outstream limit is 24. If user 2 logs in and watches all 24 cameras simultaneously in his PC, the device will allocate another 24 Mbps to that user. Now downstream in this case is 48 Mbps and upstream is 96 Mbps. Also, outstream limit is 48. Thus, one more user can log in and watch just one camera in mainstream. If this user tries to watch one more camera, the device may drop frames or live view of cameras can get stuck for a while. This is solely because the upstream of the device is reaching its limit. To overcome the limitation of upstream, optimized bandwidth feature is used. Optimized bandwidth flag will enable automatic switching between main and substream of IP cameras. All IP cameras have two video streams, namely mainstream and substream. Bitrate is generally kept high for mainstream and low for substream. In the previous scenario, the assumed bitrate, that is 2 Mbps, was for mainstream. Let us assume the bitrate for substream as 1 Mbps, that is half the value of mainstream. Also assume that optimized bandwidth flag is checked. When user 1 watches all 24 cameras at the same time, the bandwidth allocated to the user by SATATYA device will be 24 into 1, that is 24 Mbps. So downstream in this case is 48 plus 24, that is 72 Mbps, but upstream is 24 Mbps. First 48 is because of the recording streams and the second 24 because of the live streams. Also, outstream limit is 24. When user 2 watches all 24 cameras at the same time, the bandwidth allocated to the user by SATATYA device will be 24 into 1, that is 24 Mbps. So downstream in this case is again 72 Mbps, but upstream is 48 Mbps. Downstream will remain unchanged as now the device is transferring the stream to the user. Also, outstream limit is 48. When user 3 watches all 24 cameras at the same time, the bandwidth allocated to the user by SATATYA device will be 24 into 1, that is 24 Mbps. So downstream in this case is again 72 Mbps, but upstream is 72 Mbps. Also, outstream limit is 72. Now, as the outstream limit is reached, the device will not be able to stream any more cameras. If the user starts the stream anyway, maximum stream limit reached error will be displayed. To overcome this, the current users will have to stop watching certain number of cameras. This completes all the parameters. Thank you for watching this video. For further queries, please contact Matrix Technical Support Team.